for those who aren't familiar with radiation damage, neutrons damage components like this primarily through two rough families of mechanisms. So the first one, which is more commonly talked about, is that particularly fast neutrons can collide with atoms. For the purpose of this talk, I'm going to focus on tungsten as an example of a plasma-facing material, but you could substitute in a different material here. And so when a neutron collides with a tungsten atom, it can give that atom a big chunk of its energy. And what that atom does is then get displaced from its lattice site, its spot in the regular periodic structure of a material, and it can even displace other atoms. One of these collisions can lead from anywhere from 1 or 0 displacements to hundreds or thousands of displacements, depending on how much energy is transferred. And those displaced atoms take the form of two defects, one a missing atom or vacancy, and one this extra atom in a place where it doesn't really belong, or an interstitial. Those individual defects actually cluster into larger defects, such as voids, which is just a missing chunk of atoms, or loops, which in this case could be, is a term that could describe an extra sheet of atoms that is almost just like plugged into a place where they normally wouldn't fit. Similarly, much slower neutrons can interact in different ways. They're much more likely to be absorbed by a tungsten atom, and that absorption through further radioactive decay can lead to new elements. In the case of tungsten, we really care about rhenium, which is just the next element over in the periodic table. And the reason we care about it is if we accumulate enough of this rhenium, we can actually precipitate out new phases. So instead of a sea of tungsten with a few rhenium atoms sprinkled in, we now actually have a small pocket of a completely different material even. It's now a tungsten rhenium phase. So there's a set number of tungstens for every rhenium, and it takes a different structure, and it kind of actually wreaks havoc on material properties. So all these clusters are what we see when we expose materials to radiation, and they're the things that impact the material properties, like the strength or its ability to be deformed, its ductility. There's a whole host of properties, and in general, radiation exposure and these defects make the properties worse. And so we really need to understand that if we're going to design an effective fusion reactor.